In the current demonstration, we describe a spreadsheet which allows us to compute accurately the value of the first quartile of the normal distribution, and also how to compute the outliers of the normal distribution using the 1.5 times IQR rule. Let's begin with the values looked up in the tables in the previous demonstration. We recall that the z-score of negative 0.67 was 0.2514 and of negative 0.68 was 0.2483. These were the closest numbers, the closest values of the probability to 0.25 in the normal table. Therefore, the first quartile of the normal distribution lies somewhere between these two z-scores. I'm going over some of the comments that I put in the cells to explain what we're doing. So here are the z-scores. The interesting number is here. Suppose I'm interested what to put in this cell in order to obtain the value of the probability to be 0.25. This is my approximation to the first quartile of the normal distribution that I shall obtain by interpolation of these two values. I will explain what interpolation means in the comments right here. Okay, so what's happening? The interpolation consists in constructing a straight line passing through the points A2, B2 and A3, B3. That means the z-score and the probability values corresponding to the table values, to the table lookup that I perform. Okay, so given 2 points, it's easy to see that the line passing through these points has this equation where y is the slope times x minus a2 plus b2, and the slope is given by the equation contained in this cell, b3 minus b2 divided by a3 minus a2. I subtract the y coordinates and divide by the difference of the x coordinates. So that's the slope, 0.31. Given the slope and the equation of the straight line, I'm seeking a value of x for which y is before, that means 0.25. So the solution for x, the first quartile, is obtained by solving this equation, and as you see, it's a2 plus b4 minus b2 divided by the slope, which I have right here. I put this information in this cell, the interpolated value of the z-score, that means the first quartile. So let's review what's in this cell. Well, it's right here, a2 plus b4 minus b2 divided by d2, which is exactly what I have in this formula. Therefore, the interpolated value of the first quartile is in this cell, and I outlined how to compute it. It should be noted that the normal curve or the distribution, probability distribution for the normal standard normal variable is not a straight line, but that's the principle of interpolation. I replaced it by a straight line and computed the value of x. And this value typically satisfies, it's much more accurate than the original value that I obtained roughly with precision 2 digits by considering the very first quartile to be either negative 0.67 or 0.68. So the interpolated value is much more accurate, and I should assume that the 4 digits of it are accurate, which is sufficient for WebAssign. Well, let me just use the information that I just computed to solve one of the exercises, web-assigned exercises, which is to compute the outliers of the normal distribution. So, using the 1.5 times IQR rule, I should mention, because there are other ways to consider, to compute outliers. So here I have the interquartile distance. As you see, it's Q3 minus Q1. However, Q3 is negative Q1 due to the fact that the distribution is symmetric. In the next cell, I just compute 1.5 times the above cell, just to see that I indeed do that. And finally, I'm ready to add the third quartile plus 1.5 times IQR to compute the outliers. So here is the number. After some simplification, the number is negative A4 plus B13. And so here this tells me that I should consider a z-score an outlier if it's above 2.698. This concludes this current demonstration.